Let's solve LeetCode 53 maximum subarray. This is a medium tagged array question. Let's read it. Given an integer array nums, find the subarray with the largest sum and return its sum. It also tells us that a subarray is a contiguous non-empty sequence of elements within an array. Suppose we're given this array. The most brute force way we could go about this is to explore every single subarray starting at each index. What do I mean by that? We'd initially start at index 0, consider this to be a subarray, this another, this another. Now when we reach the point where our last element of the subarray is the last element of the entire array, how do we move forward? We go back and repeat the same process from the next index. So we now go to index 1 and then start again. This is the subarray, this is a subarray, and so on and so forth. We continue until we've explored all possible subarrays. Now we also have to keep track of the largest sum. So let's code it up. We first need to initialize a variable that would help us keep track of the maximum sum we've encountered so far. We're going to initialize this to the very first subarray, which is nothing but the first element itself. Now we want to figure out where the subarray starts. So we could do that using a for loop. So for I in range length of nums. And we also want to keep track of the current sum of the subarray, right? So we're going to initialize that to 0. Now we know where it starts, and we also have a variable to keep track of the current sum. We want to figure out where it ends. For that, we're going to use yet another for loop. So for j in range that starts at I and goes up to length of nums. Now within this, we're going to update our two variables, current sum and maximum sum. So to current sum, we just have to add the current element. So current sum plus equals nums of j. And then for maximum, we need to do a small comparison and update it. So we do max of max sum and current sum. Now once this is done, we can just return max sum. Let's see if it works. It does. But if I submit it, there are some test cases that are so long that it would give me a time limit exceeded error, which is not something that we want. We get our error because we are using nested for loops. That means our time complexity is O of n squared, which is okay, but we can do better. So we're going to use something called Kadane's algorithm. This is a dynamic programming / greedy algorithm that is used in array problems to reduce the time complexity to O of n. The intuition behind Kadane's algorithm is that any negative numbers in the array will only reduce our sum. So we simply do one pass over the entire array. At the beginning of each iteration, we check if the current subarray sum is 0. If it is, then we discard the subarray and reset the sum to 0. Let's code it up. Just as we did before, we want two variables. One is max sum and one is current sum, both initialized just as they were before. We're going to use a single pass over the entire array. So we're going to use a single for loop. So for n in nums, we first want to check at the beginning of each iteration if the current sum is negative. And if it is, we want to reset it to 0. We're going to do that using the max function. So current sum is equal to max of current sum and 0. After this, we're just going to add the current element to the current sum. So current sum plus equals n. And then finally, we're going to update max sum. Just as we did before, this part doesn't change. So max sum, comma, current sum. At the end of it, we can just return max sum. Let's see if it works. And it does. Let's try to submit it. As you can see, it is accepted. There is no time limit exceeded error with any of the hidden test cases. We've now seen how to solve this maximum subarray sum using two methods, brute force and the much better Kadane's algorithm, which is used in array problems to bring the time complexity down to O of n. Hope this helps.